No, appreciate that. I really looking forward to you. You know what really helps just having you all out here.
Well, this guy, he's a genius in this group.
Yeah.
I do all the talking, and he's a genius. So definitely, I'd like
I'll
to
say a few things. I won't let him say everything.
But the young man in the back there,
Yeah.
you did just meet Heath Nick.
Good.
Yeah.
Okay,
And,
that's right.
but if you ever make it through Salt Lake on any of your travels, that's where our corporate office is at.
Yeah.
We'd love to have you just come in and
Do that.
chat with Sean. He's our director of
I
engineering.
head out to Wendover every once in a while.
Mhm.
On Potash's board and they got
Okay,
some operations out there. So
okay,
I'll do that.
great.
Looking forward to.
Bill, do you have a card? Yeah.
Okay.
Okay, I'd just like to get your cell number. Yeah, as long as your cell number. Here's mine as well, so let's exchange. And I'm gonna share this with John here.
Absolutely. Thanks.
You bet. Dave. Let me forget to take a picture and give you the. Otherwise my wallet gets so fat.
I kind of feel like it's more important.
Okay. Okay, go. Yeah, we're ready. We got a lot of talking to do.
Yeah.
All right.
Good afternoon. Today we've got unique speakers. As you can see in front of us, we have three different speakers. They're going to talk to us on different experiences. So we start the introduction with Mr. Neal Stanton. As you can see from his that he's joined the company is going to represent here today. He joined that company in 2003, and he's got more than 17 years experience with explosives. And then before that again, he also has 4 years experience with Orica, and then with BME, and 4 years running background from explosive related companies. He's also a graduate in mining with University of the University in mining in 2006. Also, he also had an MBA and also a retired military corps as a lieutenant. So today he's going to tell us his own experience in the mining industry concerning explosive and whatever happened. Let's put our hands together for Mr. Nick.
All right, thank you for that. Thanks, Vanzo. So first, before we get underway here a little bit, I've got a couple of guests that I brought with me. One is John Stickrod. He actually works for Orica, and we're going to go through a talk today that's going to cover a little bit about Orica, and then we're going to jump into some of the logistics of manufacturing. I tried to label the talk about where does the boom come from, because that's really what most people know how to use products. You go out and the products themselves are pretty much very similar, very similar. Now, John being from Orica, he'll never say that publicly, but me being ex-Orica, I can say that publicly, right? So, but I think it's really key that when you go into industry and you end up having someone talk to you about explosives, that you kind of have an understanding of what where's the background at, where's the manufacturing of this product coming from, so you have this understanding on, why is this guy so much maybe more expensive when you get a proposal from him than this other guy, and it begins to really kind of make sense, and you'll as young engineers you'll get it from the periphery, and then you'll end up being in charge of those kind of proposals as you go forward in your career. So anyway, John Stickrod, he's from Orica. He's going to talk here a little bit. He's got some cool products he's going to talk about. The other man that's in the room that maybe you don't know is Nick Overlease. And Nick is the mastermind of our estimating department at Thiess. And Thiess is a fairly new company in North America. Has anyone heard of Thiess before today? Only international people. So, yeah, that's right. And, but, we are really well known in Australia, Indonesia. Really that, we got, a lot of mining to be doing actually in India as well. And, but we've been around for about 85 years. So we know just a little bit about what we're doing. And, we tend to work with really large equipment, like 150 ton plus. That's tends to be our history. And, we've loaded 600 ton trucks. We've done a lot in the space of mining. We currently operate, I believe we're going on 24 mining operations internationally. And, we actually have one here in America, which is what kind of brought Thiess to North America. And that's up at Climax. So we do contract mining at the Climax mine in parallel with Freeport McMoRan. So why don't we get started here? All right. Are you going to run the slides?
I will.
Okay. No, this one you have to do.
Okay. So I'll ask the same question differently. How many of you have heard of Orica before? All right. I hope that's the case because our corporate North American headquarters is here in Denver. We actually just moved into our new office space, which is near IKEA down I-25, a couple blocks from there. So yeah, a nice space. Anytime you guys have an opportunity, want to get down there, please let me know after this. And we can give you guys a tour and talk over anything more specifically if you'd like.
Thanks, John. Does everyone in here carry business cards still? No. So what I will tell you as students is that you need to have business cards. When I come here, I really want to take your name and number back with me. Because to me, you're all my next employee. And that's
mine.
Like I said, I want you to give them to me. All right. So but anyway, just give that some consideration. We've got some cards that we would hand out to you, but you're going to lose them. But you will find both John and I on LinkedIn. And so maybe that's something we can make sure it gets passed to you because you can always stay in touch with us there. But I just say that so that you know that just because we're here one day and maybe your entire life, you actually don't have to be without us for your entire life. Okay. All right, let's go ahead and move forward here, John. You want to run that?
Sure. So just an introduction to Orica. If you haven't heard of us, we are the global leader in the mining and construction quarrying space as far as explosives providing. We have currently about 30% of the market share globally. Across the world, we're conducting 1,500 blasts per day. It sounds like a lot. And we've been in the business for over 140 years. Compared to competitors, we're spending a lot more on research and development than anyone else. And some of that happens here in Denver. A lot of that happens in Australia and some in Europe as well. So that's just a snapshot of who we are. And this is the footprint of where we are globally. We really don't have a true global competitor, but we do have strong competitors in various regions. So as you know here, we have a global presence. There's over 50 countries that we're supplying to it as far as customers in more than 100 countries worldwide. So our presence, like I said, is strong. We have offices that are primarily here in North America across each region, Europe, Asia, and Australia, of course, and South America. But we have major manufacturing sites around those different regions with respect to ammonium nitrate, which, as you know, is the real important base material for explosives. Typically makes up about 75% of the bulk explosive for which I'm responsible for. We do some work with cyanide across the globe as well. Emulsions, packaged explosives, and initiating systems. One thing that Neal asked me to talk about a little bit was if you were to look at North America and understand where the commodity mining is happening, It's important to have that as a basis. So in terms of each of those commodities, I'm just showing here, you know, what the percentage is of the tons in North America and how it relates to what it is globally. As you can see, some of the, how's this work? Oh, there we go. Some of the major reserves, right? Western Canada is a hot spot. Mexico has been stable. In the US, particularly the western part of the US, a lot of activity with a lot of different commodities, more quarrying in the eastern part of the US, and then across Canada, mainly underground, but a lot of reserves in those precious metals, as well as obviously nickel becoming a commodity of interest. Anybody know why nickel would be of interest more so now? Batteries, yes. We see more Teslas on the road every day, so batteries are a primary downstream user of the nickel. So
Could I ask you if we could just speak a little bit more loudly?
sure, be happy to. Could I ask you to come closer? Where are we gonna meet in the middle?
Sure.
Okay, I'm waiting.
Move up when I heard.
All right.
You want this one?
Sure. So what I wanted to show next is really what it takes to support all of this commodity-based mineral mining within all of North America. So as I mentioned earlier, ammonium nitrate is a big demand for that, and how we actually locate ourselves relative to where the commodities are is an important attribute. So next slide, Neil, shows, I'll have you toggle back and forth between the two.
Yep.
But if you take a look at where we showed the commodities, here's where we're showing the demand to be based on the actual volumes needed, you know, for those specific areas across North America. So go back and then go forward.
Oh, back to this one.
Yeah. So I just wanted you to get a sense for where the AN demand is relative to where the commodities are, and they should be somewhat over an overlap. You could go back again. You guys catching that? Go forward again. So obviously what we're looking at is where's the demand, you know, by the mineral region, as I showed in the previous slide. Now, if you go forward one more slide, here's the extent of what the AN manufacturing coverage looks like. So when you look at this, you're like, wow, there's a lot of demand across the region, but there's very few AN manufacturing locations, quite honestly. Anybody know why that would be the case? So an AN plant, ammonium nitrate, requires the reaction of ammonia with nitric acid. Okay, that's a very exothermic reaction. You want it to be at a decent scale because the plant.
Hey, John, just give a second.
Sure, the plant's all right. Okay. Testing. Is that better? Needs to go up more?
Yeah.
Put on control is on podium.
It's on me.
Oh, it's on the volume there.
Yeah. It's one extra. It's okay.
All right. Is that any better?
Yeah.
Thank you.
Okay.
Thank you.
So I asked the question, why are there very few ammonium nitrate manufacturing locations in what is a very vast market as far as demand? Ammonium nitrate is very expensive to manufacture as far as the makeup of the plant and the process. So what we're doing is we're strategically locating our AN manufacturing to support where the demand would be. In this case, showing you here, between us, those in orange, and those of our competitors in terms of where they're sourcing AN. And a lot of times the AN manufacturing source is based on a larger volume of fertilizer being produced compared to ammonium nitrate for explosives. So we do partner with those companies that are manufacturing fertilizer as well to make our industrial grade ammonium nitrate for our business.
So one of the other things I'd like to say about this is that these locations, like when you get into the field, you say, well, gee, I want to get my product from these guys, and I'm out here in Nevada. But the product that I'm buying is actually from Orica, and their plant's way up here. I go, well, why is that? And it's competitive marketplace. The marketplace for Cheyenne, if you recall, Wyoming, what's Wyoming known for? Coal, exactly. You know how big a hole they put nitrate in coal? Like this big. You know how big a hole they do for gold? Like this big. So the volumes are a lot different. And so those are just kind of the just really high level kind of aspects of mining that as you go through and you understand commodities, because copper has big holes too they fill. And so you'll see that Cheyenne, when Dyno built that back in the 50s, they built it for our they built it for the coal that's up here in the Wyoming. And so it's just it's logical that all this product that they can get to go just north of them by about 100 miles is a lot better than taking product from here and coming down 900 miles. So that's some of the competitive landscape that you see. Same way with some of these plants here. If you saw this map, probably about 15 years ago, you had plants here and here, and we had another plant over here. I mean, there was a tremendous number of nitrate plants. Those nitrate plants were all kibosh. They're shut down. They're not even existent anymore. Most of them, it's amazing. Most of them were actually taken down, and then they were moved internationally. So they weren't wasted necessarily, but it took a lot of money to take them down and move them internationally. And I know Orica took down the Seneca plant. There's one up in Wyoming, in Wisconsin that was taken down. And some of those plants were actually put up during World War II to support the requirements for explosives in the fight. And they were taken down though when truly you could not make any money out of selling nitrate because the supply was so great. And so they said companies that had lots of money invested in the capital of that equipment and that manufacturing plant actually delivering to the marketplace, to their footprint, that footprint just simply didn't have enough nitrate to consume all their product. So then they had to start shipping it everywhere. And that's when the actual profitability of those plants just tanked, and business decisions had to be made about closing them. And so that's why, like, when I wanted to talk about, where's the boom come from? This is it. You saw all the commodities that are in this North American landscape. Well, when you think of drill and blast, it's got to happen in every one of those mines that are out there. It just doesn't happen without the explosives being put in the ground. It comes from these locations here. The base product does. So, John, let's keep going.
Yeah, so just to recap here, right? We're talking about all these reserves. We're talking about basically where the demand is based on those reserves. We're talking about where we're located as far as a manufacturing. And now we're talking about the actual explosive. So you can see here again, compared to AM manufacturing, which I should have mentioned earlier, it's hard to build an ammonium nitrate plant for less than $100 million. Okay. It's easy to build an explosives plant in terms of bulk emulsion, in my case, for about 10 million. So that's why you see a lot more emulsion plants that are scattered across North America in this case. Again, us relative to our competitors here, just showing where those are located. And it's easier for those emulsion plants to be located on my property based on volumes. We will always consider that and work with our customers to do that so that the footprint as far as where the ammonium nitrate comes from and the explosive is made. Freight is a big consideration here. So we're always looking to reduce the freight component in the supply of these materials to the mining customers. The next slide then you know, if you look at Orica alone, this is where we have all of our bulk explosives manufacturing locations. Just noting how well that's covering the majority of the region in terms of the proximity relative to the reserves and actually the ammonium nitrate supply. The next slide is really showing you a little bit more in detail what it takes to then support that. It's interesting this side versus that side. So what we're talking about here now is we have our AM plant. And then also there are places where we need to make boosters, the emulsion plant, which I showed you in the previous slide. And then det cord, detonators and packaged explosive. All this is part of our network and our portfolio of products. So now we're starting to see that build. You go to the next slide. The coverage here, you know, very similar. Go to the next slide. Now you can see all the support that's needed to actually store the products. So we have our magazine sites here. We have our bulk sites where it's made at an explosive plant, and then it's moved to a site that's even closer to those customers. And that's where we have what we call our mobile manufacturing units that actually go out on the bench and load the explosives. So there's a lot of a network here. There's a lot of coverage aspects to it. And here, each one of those dots show that we have Orica personnel there that are managing some aspect of our business. So that covers coverage. Is there anything else you want to talk?
I don't think so. I think we're gonna run out of time.
Okay. Last thing I wanted to talk about, Neal asked me to talk about, is basically our technology portfolio, which is pretty vast, and we actually employ a lot of different types of engineers. I'm a chemical engineer. We have electrical engineers. We have mining engineers. We have all kinds of other specialized engineers as part of our groups based on what we're trying to accomplish working with our clients. Obviously, the first step is to know and use the resource info. We expect a lot from our customers in that regard, but we help them if they need it to really uncover where, you know, the ore concentrations can be within, you know, whatever property that they're looking at. We are really strong, obviously, in the middle in terms of blast design and looking at those dynamics as input from the drilling information that's provided. From there, we can execute the blast. We can either do what we call a total load service, or we can leave that up to the customers. But the key thing right now, and probably in the last 10 years, has been how do we do outcome measurements? How do we actually leverage the information from the mine to incorporate better fragmentation measurement and optimizing that blast so that they're getting the majority of what they want in terms of size and material? Next slide. So our portfolio, like I mentioned, it's fairly vast, but if you take a look at these in terms of their quadrants, what we're showcasing is the amount of information that we're and the effort that we're putting into tracking a lot of information for the customers. And that's part of our digital solution suite. We call it Blast IQ. So with Blast IQ, we're taking information from the bench ongoing through the blast process. And we're using that as a mechanism to change the energy in which we're putting into the blast design in terms of our products. Bottom right, for instance, looking at some of the license to operate issues that our customer has. You know, a big thing is nitrates in the groundwater. Well, what did I mention in terms of how much ammonium nitrate is in a typical explosives? 75%. So their concern is, how do we minimize that? So we've developed specific products, in this case, that are very thick products, almost the consistency of a Vaseline. And people who know that consistency can be difficult to transport, to move around, right? To pump it, to put it in the right locations. What we're able to do is devise a manner in which we manufacture it at kind of the peak viscosity that it can be coming out of the plant and still be transferable into these mobile manufacturing units, and then actually thicken it even further on the truck so that when it goes down the hole, it's got a consistency where it's not going to leak in the cracks and crevices. It's going to retain the sensitivity of the product longer so that you get an ideal blast scenario and you have no nitrates, you know, being as a residual into the groundwater. So that's a key trend that's happening within the environmental landscape of mining these days. Groundwater concentrations as it relates to nitrates, any other contaminants is really an important aspect that we're working with our customers on. Another example or another aspect is fume, NOx. More and more of these particular mines or quarries are getting closer to communities. And communities are sensitive to the blast vibration, the noise, and any sort of airborne gases or emissions that we call nitric oxide or nitrous oxide based fume events that could occur. So we're always taking the information that we get, feeding it back into Blast IQ and giving the customer basically an improved outcome every time we blast. Lastly, the other piece here I wanted to mention on the bottom left is our wireless initiation. So the days, when you go on the bench and you see all the cords and all of the lines that are all over the place, particularly underground, it becomes a massive kind of web of wires. So that's all gone away with the ability to initiate the blast wirelessly. So we have a certain wavelength that we can operate within, kind of like the military standards in which we can do that now. So that's one of our newest initiating systems is wireless jet detonation. So that's pretty much all I had.
So
We have enough time.
I think we're looking pretty good here. So one of the other things that I wanted to just talk about on the manufacturing side here is that when we have these plants spread throughout the United States, like there's rules and regulations about those plants and how you move product around the United States. It doesn't just show up in your pickup truck, right? There's placarding that's got to happen. There's boxes, day boxes or trucks that you got to be able to move around in and have all the correct items. And there's different companies that do that. The company that's local here that supports Orica is a company called Southwest Energy. There's a company that supports Dyno Nobel, it's called Buckley Powder. And then there's smaller companies called I actually, when Manzo was talking about running a company, I ran a sales and distribution company, not a manufacturer, but I had the wherewithal from my time with Orica and these other companies to how to move and sell product. And that company name is called Explostore. And so it's each company has kind of its unique capacity. Explostore being a small company, we could not afford a big bulk truck. So we had a truck and a day box, and we ran around and supported a lot of construction projects, blasting for homes and blasting for roads and blasting for some small quarries and things like that. But it takes a lot to make explosives to get the boom to the hole, you might say. And that's really what I wanted to share with you today is that if you come across your anything in industry, you really do have three guys in the room here that would be willing to address the issues that you have. And whether we're part of the your proposal process or just part of you're just wondering if it would work, because sometimes that's just the way that you need to get questions answered. And I'd say, keep my number, keep the knowledge of my name, I guess, because unfortunately you can't look me up on LinkedIn yet as the blasting guy. Otherwise, I'd say just remember that. But that's what I'd like to share. What kind of questions do you have that John, I, or Nick could maybe answer for you? Yes, ma'am.
So I always have questions, but most immediately, we have research laboratory out at the Edgar Mine.
Yes, ma'am.
I'm wondering what kind of research do you think we could be doing at the Edgar Mine or at the Explosives Research Laboratory that would interest industry?
Well, that's a great question. And it's one of the things I know that as I stepped out into industry, getting away from being in the manufacturing side, that I saw some things, right? Certainly, if you go back to your last slide, certainly this one here is huge, the no wires. Because that is one that industry has always had a challenge with, right? It's like, is it hooked up right? And if you don't hook it up right, then you get cutoffs. And so this eliminates that. I mean, right now, John, this is still quite an expensive product, right?
Yeah.
And so, but if you recall, there is a product that's on the market right now called the electronic detonator. Most of you heard about that? And that product really amazingly started out where the price point of this product's at now. And it's hard to even fathom because electronic detonators are used almost throughout the entire explosives community today. It's only us cheap guys that do construction that would throw the non-electric in the ground and have it go off. But that is one of them, Priscilla, is that kind of solution of you know, you don't necessarily, you got to know some technology with this kind of product, right? You don't have the wires to go and check. So now you got to rely and trust the technology is going to deliver the solution that you want. And so that would be one. Now, the other one, product wise, I'd say some of the stuff that John was talking about, the viscosity of something. And if you're doing trials up at the mine, you know, really working that concept, you know, how close, I don't know if you guys know this, but explosive products have what they call critical diameters. And like most explosive products, if your diameter is just as big as my finger, it's not going to go off. It'll burn, but it won't go off. But as soon as you start, there is the critical diameter that's like literally like, what is it? 3/4 is the smallest that we have. Like it's 3/4 inch in diameter, it will go off. And so that is another aspect of like, if you could figure out how to make something come out of the hose and stay at critical diameter, not just mesh down to where it's no longer at critical diameter, then you have something that industry possibly could use again.
Something I mean, is there an issue at all, or room for improvement by having a better control on detonation timing? Or is there still an issue with water in the hole that needs to be addressed?
So water is normally, we overcome that currently with the emulsion product that John was talking about. You want to throw that slide back up?
Sure.
Now?
I'll just mention on that front is that we do have emulsion chemistry that we're able to sleep the product for 6 months in the hole. So it's something we've been able to overcome. I guess to your earlier question, a lot of the development activity that we do, we're working to do this with charges that we can easily detonate underwater. And that's why we work with an underwater energy lab here in the States to accomplish that. We have blast tanks that we do a lot of the small charges when we're doing development work, you know, in the lab. So I feel like we're pretty centered around the ability to do most of our development work based on doing it at this underwater energy lab. But the key thing, as I mentioned earlier, is when it comes to leaching of different materials out of the products. And if there's any opportunity there to measure leaching rates, that would be something that would be important, because as we develop these products and we go with thicker products, higher viscosity, we're always looking at, you know, how to test the leaching rates associated with those different, you know, options that we've developed. So
one thing we should mention, I don't know, Neal, if you're aware of this. We have an Orica drift up at the underground Egger mine. We did 45 rounds as part of the development work for the electronic beds.
Okay.
Yeah, so there was a lot of work that was done up there on that. Also on the emulsion, some research activities that were done between us and DOD in the Joe Reynolds property is the development of a new type of emulsion that the military was looking to buy. So we did that also in the other
Right.
property store. So we've got a long research relationship with Orica in a variety of things.
And we want to continue to do that as well. You know, we still have a lot of the development activity happening in the region. And we have some things that, you know, we probably should talk more about in terms of our technical folks being able to know basically the capabilities that you have in order to do more.
That'd be great. I was curious on the list, Neal, you know, the new plant that's being built by Southwest in Nevada, is that with Orica?
Yes,
Okay.
Yeah,
All right.
we're part of a joint-
The operation.
we're part of a joint venture. And we're actually have technical folks within our Denver office that are helping them to commission that plant starting in December.
December.
Yeah.
Okay. I was curious. And then,
So you know what that will kind of replace, right?
I don't know.
So that, long time, how many people have been to Salt Lake recently? Okay, so Salt Lake is, it's confined by a couple of mountains, right? And it's got a big mine on one side called Rio Tinto. And, there's a place that used to be quite rural called, Lehigh. And Lehigh's had, I think it's actually had 2 manufacturing plants, for emulsion companies. And in that location, Orica's has been there for at least 35 years. And well, literally the town has engulfed it. And because of scales of distance and things of that nature that are all regulatory compliance arrangements, Orica's had to say, oh, we got to move this out of town. They simply can't keep manufacturing. So there used to be, if you saw on the map, it was a place that was out here in Nevada called Battle Mountain. Have anybody been through Battle Mountain? So that location is, you blink, you're past it. I think it's a 2-exit town, which is, that's where you measure towns in Nevada. And but that town had a manufacturing plant there at one time. It was ammonium nitrate plant. And Dyno, when I talked about supply and demand, that plant was so far away from its raw material inputs that they had to rail everything into it, and it just become non-cost competitive to moving product down. If you believe this, moving product down from Carsland up here in Canada all the way down into Nevada. So that's I mean, the economics. I haven't been around when those economics were being run with Sandy Rudolph, and it was absolutely amazing to see that the freight disparity was actually involved in the economics. So, but now what they're doing is Southwest is taking a manufacturing plant that used to manufacture all the emulsion out of the Salt Lake area and have to transport it into Nevada. They've cut down all of that transport costs, and now they're going to manufacture there in Nevada and move the product out to the mines. Be much more efficient, and definitely they'll have scales of distance available in Nevada. Any other questions?
What exactly does Orica do here in Denver? Is it more administrative or like research and development?
Yes, so we do a little bit of both, depending on the nature of the technology portfolio that I showed. There are people here that do all of the blast design and modeling pieces, working with, you know, our global network, but the expertise resides here. We do have some underground engineers here that are renowned for the work that they're doing to solve problems across the globe. So they travel out of Denver in order to do that. We have our corporate functions in the Denver office as well. So, but we do have people that work with the global development group that's based in Australia with expertises that they've been able to build by being here and associating with the Orica network as far as our customers and the know-how around tech services in this area. So a lot of the digital solutions piece is here, the underground piece, and then we have a very strong technical solutions team.
Sir,
Yeah, I just want to ask that the reduction of the ammonium nitrate content in your explosives,
Now,
won't it reduce the energy required for very good fragmentation? And as well, if you're reducing the content, what else do you have to increase the energy? That is my first question. My second question is that most construction work really want to get rid of explosives due to the permission from the government and so many things, so many environmental concerns. So what's the future of the explosive manufacturing companies in this context?
yeah, so your first question, we're not reducing the amount of ammonium nitrate. We're working on how the residual nitrate is reduced. So this is the residual that, as Neal was talking, if the product were to reach its critical diameter, that's all residual that could make its way into the groundwater or the tailings pond of the mine and such. So the content of ammonium nitrate is not changing. The thicker product actually promotes the ability to keep the sensitization there longer, and it doesn't cause within a standard borehole for it to be pushed into cracks and crevices where it would go down to the critical diameter or below. So it's all about the residual. So it's an environmental situation in which the mines are looking at their ability to meet the thresholds as far as the nitrate levels in the groundwater that before they release it into the local rivers and streams. That said, mining activities contribute less than 5% of that. Agriculture, the vast majority of the nitrates come from that. So now to your second question, which was more about what?
Yeah, that most construction wants to get rid of the explosive section. I mean, they don't want blasting.
Yeah.
Due to the permitting, due to sort of environmental concerns. So now, what's the future of the explosive manufacturing companies in this context?
For us at this point is to put the right amount of energy in the hole all the time. That way, you're not producing more NOx or more nitrates. You're having an optimized blast every time. Ideally, the nitrates are going to get consumed completely in the reaction of the blast. That's number one. Number two is there are some developments around other materials that aren't ammonium nitrate based, things like hydrogen peroxide, but they carry with it a lot of cost and safety concerns at the moment. And we're keeping our finger on the development of those types of disruptive technologies relative to ammonium nitrate in the explosives. I'd say those are the two main areas: optimizing the blast performance so there's no residual nitrate, because it should all be consumed within the blast, and looking at other materials that might have a benefit for certain types of blasting, like construction based, more than typical blast hole, blast design, blast patterns within a normal open cut mine.
so that's it's a fair question to ask, but construction is minuscule to mining when it comes to explosives. So whether construction wants to use it in the future, it's up to them. It's not going to impact the life and times of the manufacturers that are here. So it really, construction would have to surge probably 100 times what it is today to have an impact on the manufacturing capacity that's available at these plants. So if they decided to drop out, these guys would still manufacture their explosives, which I think is what she was trying to kind of ask. Dr. Rastami?
Yeah, actually, thank you for the presentation. You talked about bulk ammonium application, but what's your fourth product? You have detonator, you have primary boosters,
Yeah.
all type of accessories. What else? And also you have prepackaged material too, right?
We do, yeah, and all the manufacturers do.
Right.
You know, I know this is a Orica centric, but you can
Right.
put Dyno on it, you can put Austin on it, you know, it's something that's there. But as far as what Orica has, like, it's a full spectrum. What do you want? We got it.
But I mean, I always look at it from that explosives train perspective and know that, you know, obviously you're talking about some really high explosives with the detonators. So PETN based materials. So we got the detonators, we got the shock tubes. We got all kinds of different types of detonators, whether it's non-electric, electronic, and now wireless. So that's all on the very start of the explosive train with the initiation. And then within the actual explosive column, the blast hole is filled with either packaged explosives and a variety, whether you want it to be booster sensitive or det sensitive, with the bulk explosives that are actually pumped in by the trucks. Then you're talking about a variety of different formulations that are dictated by what the customer's application needs are. And then where we've gotten a little bit more broad in terms of our portfolio is this digital solution piece, where we're working with the customer to constantly associate what we're doing from a blasting perspective to the tracking of what they want from an ore perspective. So fragmentation tracking, ore tracking, those sorts of things. That's a whole new area that's an adjacency that we're working with our customers on under that Blast IQ portfolio product. So.
Yeah, so give me a little bit more on the customization of the emulsion that goes into the mold. I'm assuming that you have that capability, right? To customize it.
Yes, so we do. We're referring to that as our 4D technology. And basically, when you take a look at the measurement while drilling data, the compressive strength of the rock, then you can feed that into what we call Shot Plus.
Yep.
And then we have the same software on the truck called Load Plus. They are integrated with one another. So Load Plus basically takes that information and dictates what densities do we need to be loading and to what difference across the pattern to get the appropriate, I guess, blast outcome that way. So we're always adjusting density in order to get the appropriate energy for the rock strength.
That's on site and the blast.
That's on site. That's happening right on the mobile manufacturing units. So that's one of our latest technologies, is to tie all of that data from the drilling into the blasting, as far as what is the required energy to break the rock that has a certain compressive strength range.
And the drilling manufacturer, they have this platform that you can use as far as drilling data that they transfer to you?
Yeah,
Thunderbird or.
Yeah, we started with some of the bigger open cut mines in this regard. And so they always had that drill capability.
Right.
And for us, it's like, okay, they're saying, well, we have all this data. Okay, what are you going to do with it?
Right.
And then we got to the point where first we tracked it, we analyzed it, but then they're saying, well, okay, your analysis says you need to change this from a blasting perspective. And we recognized that we had to build that capability into the truck and also into the product in order to basically achieve the outcome they were looking for based on having that data.
And densification, you mentioned you do that by use of metals. I mean, what is it exactly that you use to densify your emulsion as you clean the color?
Oh yeah, so most of our products, we use a gassing system. So we're able to sensitize based on a gassing solution that provides all the hot spots there. And so we can vary the amount of that that basically then dictates what the density would be.
So the last item that I'd say about what do these normal commercial manufacturers of explosives actually produce? And the question is say, well, what don't they produce? And the one item that I know that, like, they don't produce is plastic explosives. So there's a big variety of uses of plastic explosives. Military is probably the number one because it's easy to carry, it's very robust, it's kind of like a cast booster type thing. But you know, Orica doesn't make plastic explosives. So
Our policy as of 3 to 4 years ago is that everything that we do from a commercial transaction perspective is mine related. They have to have their licenses and they have to be tied to, in the US, the ATF, MSHA, and that sort of thing. Things like tannerite for targets and Kinnepack, which is a product. Those were outside of that commercial transaction policy, and we actually, you know, sold those off to other companies to be able to manage that. That's just our philosophy. It's a safety and security perspective. Security really being the key thing right now is knowing that every time we're putting an explosive through our magazines, it's going to a mine for use. So that's just a philosophy from a business perspective that we changed 3 or 4 years ago. The lawyers got involved with that, of course.
Right. There's one question right here. Oh, a question about
somebody else is here.
Yeah, so you know, we would do that in the way that we have a distribution channel to do it. So there are components where we may do that. It's not a huge part. It's kind of like Neal was talking with construction. It's not a big endeavor for us. Actually, one of the things that's interesting and we get calls about a lot is it's either local municipalities that are trying to train their dogs on sniffing explosives so that they're trained and then they know to look, know how to identify it, like at the airport or anywhere else. We're supplying those types of materials for them and the assortment and the range of which we have so that they can train, their dogs to be able to detect it. So
I know that some of the students will have to go, but I just wanted to let you know something. Two things. One is, I think it'd be really good to have a long-term relation with Orica, with you and actually figure out how we can use the resource of it.
I appreciate that.
So I think that would be very good. I also wanted to know, have you ever heard of Curly Livingston?
No.
He was a professor at Colorado School of Mines and developed the theory of blasting. And in the 50s and in the 60s and in the 70s. And it was used for the NORAD restoration. Wall blast, the smooth wall. I'm trying to find somebody who's willing to look at the manuscript and see if it's still sensible. I'm a student in here at Colorado School of Mines. And we have all of his consulting files in a room here. Now, I don't know what to do with that. But if it's any good, it's worthwhile, because he never published it, because he developed the theory and then used it in his consulting. So if you're willing to do that, I'll send it.
I'd certainly love to put my eyes across it so I could see if some of the practices that are being used by him. Because actually that's a second professor now that I've come across. There's a man that actually used a ball pin hammer on rock, and he would match the theory that he could match the velocity of explosives with the rock, and it would fracture like to levels that you just really couldn't imagine. And it was a theory that he had. He's written a small book about it, but again, it's kind of like what you're talking about. So
yes,
yeah.
I would be too. I typed
it up.
Oh wow.
But I don't know. It's been sitting in the people, still some gems in it, and we gotta get it on.
yeah, absolutely. We have one other question right here. If you guys will just give us a few minutes, we'll try and answer them quickly.
Some of the students, maybe will be, don't take it personally.
Okay. Go ahead.
Yeah, so. As like, we are going for like new mining or like construction on the moon. right?
Yes, yes, yeah.
So we might like need explosive for that, right? So I don't know, what are you guys thinking about that in terms of like developing
I would,
explosives or something like that?
I would say that the requirements for that are a bit out in the future, right? If you tell me I can make money from it, I'll figure out how, but right now, I think there's a lot of dollars going into that that are absolutely necessary. It's kind of like the electronic detonator. John, do you remember how long that whole electronic detonator practice was? Was it like 35 years or something like that?
I was gonna say 25.
Yeah, so you get 25 years in moon mining and I'll come and talk to you about selling something, right? You got a question? Yeah.
Yeah, my question has to do with safety in regard to the transport explosives. So we had I come from Ghana, we had an incident in a small town. Where an explosive truck collided with a tricycle and leveled the host. I think 30 people died.
Yeah.
So my question is, do you have any kind of risk management plan and what's particularly circumstances we take into consideration?
Yeah, I'm familiar with that incident that you're describing, and we're always, working on those things based on, unfortunately, sometimes the last incident that's occurred. So when you take a look at the premise that we have around unsensitized explosives, is that that's the form we want to transport and store every place. The reality is, and some of those are more ammonium nitrate based, is pressure and temperature will always cause an explosion to happen, even if it's dust, right? So you hear about explosions in different industries, and that they're all based on two principles: is that there was enough of a reaction to occur where it increased the temperature and the pressure. And when you do the two of those inside a combined vessel, you're going to get an explosion eventually. So yes, those impacts and what we witnessed in Ghana in that regard is something that we're learning from, and how we design our vessels and work with our carriers around transporting those materials.
You guys, thank you for your time. And if you got any other questions, please let us know. I was gonna take you guys up to the cafeteria here and feed you dinner, but that's what, I've ruined all your appetites by serving you pizza. So, but definitely, you can come and grab my card or my information.
Okay, so here, if
That's a card that will definitely get you in touch back with us. And if you don't have John's card for some reason, then we're
Yeah, have it in the
available.
back.
Just know that. We'd love to chat. Oh, and don't forget your hats in the back. And when I come back to campus, I expect to see Thiess walking around campus. On purpose. It's a really big building. That's right, that's right. So, young lady, see you.
Yeah.
One of you.
Last minute, you'll speak. I have plenty of those. I actually, and I can come back. So I'm local, right? So the thing about it is, yeah, everything else about is positive sense of relationship. We run.
I really don't think.
That.